What does the mean value theorem say? If they're telling us to use it, we may as well know what it says.
If function is continuous and differentiable, then something about there's always a point.
Right? There's some value c for which the slope of the tangent line is equal to the slope of the line between the endpoints of a stated interval. God, I find something that writes darker. So f is continuous and differentiable. There it is. On a given interval, then we should be able to find some c for which f prime of c is equal to f of b minus f of a over b minus a. And so let's pick some interval around 0. How large can f of 4 be? So how about we go from 0 to 4? So let's pick the interval to be 0 to 4. We're told that f is continuous and differentiable and has that value, or has that inequality for all values of x. We'll start saying this, that on 0, 4, we know that f prime at some number is equal to f of 4 minus f of 0 divided by 4 minus 0. This is what we want to estimate. We have this number, and then 4 minus 0 is 4.
Don't you just want to cheat the problem?
Cheat the problem?
Yeah, because you know that the slope will never it'll never change more than 3
That's right.
per unit of x.
So I'm going to say this.
So you could just multiply 3 times 4 since you're looking for the 4th unit, and then add that to the -4.
That's exactly what's going to happen.
Okay.
That's exactly what's going to happen. I know f prime for any x is smaller than 3, so I know that this has to be less than or equal to 3. So we're going to take this thing and we're going to solve it for f of 4. We're going to solve for f of 4. You know, f of 0 is -4, so let's fill that in. We have f of 4 minus the -4 divided by the 4 here. So to solve, multiply by 4 to get us 12. Subtract 12, that keeps my less than symbol, and subtract 4. Is it 8? According to the mean value theorem, f of 4 can be no bigger than 8. Okay.
Doesn't we take the derivative to the x times log of 6x plus 4?
This log or natural log?
Just log that one.
6x plus 4?
Yes.
So we have to remember 2 derivative rules. That the derivative with respect to x of any number to the u power, use a function of x, is itself times the natural log of the base times u prime. Then to take the derivative of other logarithms, we can use the change of base formula, that the log base b of any value of x, any function of x, is equal to the natural log of that divided by the natural log of base, and then you can take the derivative of that. So I'm going to start by rewriting this. This base is a 10. So I can rewrite this logarithm as the natural log of the stuff in the parentheses divided by the natural log of 10. Natural log of 6x plus 4 divided by the natural log of 10. And now I'm going to take the derivative of this using the product rule. First times the derivative of the second plus the second times the derivative of the first.
Don't you use the quotient rule on the second?
Nope, that's just a constant. I'm going to pull it out. Here's the constant that I'm pulling out. And here I'll do product rule. So the first is 2 to the x. The derivative of the second is 1 over u prime. So here's the 1 over u. And here's the u prime. Now the other way, copy down the natural log term. Natural log of 6x plus 4. And then the u prime term is itself, natural log of the base, and in our case, the derivative of the exponent is just 1. So I'll get 2 to the x times the natural log of 2. We condense it a little bit. I'm going to have, just put this on top, 6 times 2 to the x divided by 6x plus 4. I'll write this in the front. 2 to the x times the natural log of 2 times the natural log of 6x plus 4. And I left off my 1 over log 10. We squeeze it in there. That looks like I can put it right there. Okay, yes. Sine of x to the x. Okay, we swap boards here. Sine raised to the x. Going west. So here's where you have to pay attention. You've got a function of x raised to another function of x. So here's where we use a logarithm. The natural log. We use a natural log to bring the power down. So we start by calling this y instead of f of x. Then we'll take the natural log of both sides. So I'll have the natural log of y is equal to the natural log of the sine of x to the x. And we did that to bring the power down in front. So we'll write that in the next line. That x right here, and then the natural log of the sine of x. And now we're ready to take the derivative. Bring the power down so that we can take the derivative, but the only way to bring the power down is use a logarithm. So on the left-hand side, the derivative is just 1 over y times y prime. Over here, we've got to use the product rule. So we have the first times the derivative of the second. So it's a logarithm, 1 over u times u prime. So here's the 1 over u. And on top, I'm going to put the derivative of that. The sine of x is the cosine of x. Now we go the other way, copy down the second term, natural log of the sine of x, and take the derivative of the first, and the derivative of the first is just 1. And so our last step is to multiply both sides by y. Let me write that as x cosine of x. You want to put another trig function here? What's cosine over sine? Cotangent. X cotangent of x plus the natural log of the sine of x. And then if you want, you can replace this y with the original expression. We use this little technique, this version of logarithmic differentiation, take the derivatives of stuff that look like that. So I'll certainly have something like that on your test Wednesday. We should have had it today, huh? You guys are ready? No?
The test today?
We should have.
I do that on Mondays.
What's wrong with Mondays?
Because I don't get enough sleep during the weekends.
I thought that's when everybody slept.
Depends on what time you're at bed.
Well, duh. Do you need somebody to tell you when to go to bed?
Maybe. Could you help me with that? Like,
I'll
somebody keep me
do an
up at night?
alert. I'll ding your phone or something.
That'd be-
You, time to go to bed. I'm not gonna tuck you in though. I didn't say I wouldn't tuck you. What else? You guys at home can also recommend a problem through chat if you'd like.
I had a question on 7, but like my thing's on late.
I don't know either. It was on the last web work.
Yeah, the one that I did today.
Okay, let me find that last web work. See if I can pull it up. When's due today is this one, huh? 4142?
Yeah.
Today?
I don't know.
Yeah.
Looks like it is. Which one?
That's 7.
7? All right, we're gonna find the absolute max and the absolute min of this particular function. We write it down. F of W is the square root of W times W minus 5 to the 1/3. This is number 7 on web work 4142. Find absolute max and min of f of W is the square root of W times W minus 5 to the 1/3 on the interval from 0 to 4. So our plan is to take the derivative here using the product rule. Find where the derivative is 0. Keep only those that are between 0 and 4. And then find the value of this function at each of those points and at 0 and at 4. Pick the largest one to be the max, the smallest one to be the min. Okay. So I'm going to move over. I'm going to take this problem over here to the board on this side. Think of that square root of w as w to the 1/2. Now let's take the derivative with the product rule. So here we go, switcheroo. So we've got the first times the derivative of the second. Bring the power down. Raise this to 1 power less. And multiply by the derivative of what's inside. The derivative inside is just 1. Now do it the other way. Copy down the second term. And take the derivative of the first. So we have 1/2 w to the negative 1/2. In the next step, I'm going to rewrite that so that all the things have positive exponents. So this is going to go underneath this w with the 3. This is going to go underneath this w minus 5 with the 2. So I have w to the 1/2 over 3 times w minus 5 to the 2/3 plus w minus 5 to the 1/3 divided by 2w to the 1/2. What would you like to do next? Solve this for w. Common denominator. So we need a common denominator between the 2 and the 3. So let's use a 6. Then I need this factor. Then I need that factor. So our common denominator is going to be 6 times w minus 5 to the 2/3 times w to the 1/2. So I've got to multiply that first factor. No. Multiply this by 2w to the 1/2, top and bottom. And I got to multiply this by 3w minus 5 to the 2/3. So that they have the same denominator. So here's the square root of w multiplied with the square root of w. So I just get w times 2. What do you get when you multiply this w minus 5 with that one? You get to the first power again, right? When you multiply like bases, you add the exponents. The 2/3 plus the 1/3 gives us 3/3. So I just get plus 3 times w minus 5 to the first power. Then we can simplify that numerator. This is 2w plus 3w, so that's going to give me 5w. And then 3 times that 5 gives me minus 15. And then I have this, 6w minus 5 to the 2/3 and w to the 1/2. Now remember what interval we're on. We're on from the interval from 0 to 4. So this is never 0 here. This is 0 when w is 0. It's an endpoint of the interval, so it should be a place where there's no derivative. What about the numerator? What makes the numerator 0?
Maybe
3. W is 3 is going to be our critical point. So F prime is 0 when W is equal to 3. And so we check the value of F at 2 endpoints, 0 and 4, and then at our critical number 3. And so F was square root of W times W minus 5 to the 1/3.
Well, I guess it's factoring, but you don't always have to do it like. You just have to find out what
Yeah, I do want it completely factored. Okay. It was just kind of completely factored when I finished here, other than the common factor 5. But usually I would factor from this step. Okay, so when I put 0 in here, I get 0. When I put 4 there, I get the square root of 4, which is 2. 4 minus 5 is a -1. -1 to any power, and -1 to an odd power is still -1. So out of here I get -2. Here I get the square root of 3 times the cube root of -2. So these are pretty close in size and they're both going to be negative. So probably need to go to a calculator right here. I don't have one. You want to see how big this number is? But this one's clearly max because it's the only one that's not negative. Right here. It's smaller than -2. It's smaller than magnitude. So it's farther. That was going to be the absolute min. Smaller. There's no way we could have done that without a calculator. I'll give you numbers on your test that you would know.
Between 0 and 4, so,
0 and 4 automatically part of the ball game, and 3 is a
oh,
critical number in between 0 and 4. Yes, sir.
So like on our test, like the volume or like.
I'll give it to you. Okay. Might make you ask for it first. But, no, I think I'll. Sure. Got some kids back too, don't I? Oh, I don't know. What did I do with them? Where did I put all those papers I graded? This stack. I owe you guys one. Wait, that's count 2. That's count 2. Count 2. Gosh darn it, your papers might be sitting on the breakfast floor. Well, you guys gave me papers, I don't have them. Count 2. Count 1. No fudge. I'll be on my desk upstairs. What else can we do?
Number 7, approximate the change in C of x equals 4x over 6x plus 2 as x changes from 1 to 1.04.
Okay, C of X is equal to say the end for me, please.
4x over 6x plus 2.
I lost the beginning through that error. 4x. So this is, so we're approximating the change in C. So that's delta C.
Here's what I'm getting.
It's on the review? On the review. So what I mean by delta C is that delta C would be C at 1.04 minus C of 1. We can find that number exactly, but we're going to approximate it. And our tool for approximating delta C is the differential of C. The differential in C is just C prime of X times the differential in X. DC is going to be our approximating value. So we need to take the derivative of this and then evaluate it at the nice number. Let's go ahead and get C prime. By the quotient rule, we take the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. We can simplify that a little bit. Let's just multiply through those parentheses and collect like terms. I'm going to get 24x plus 8 minus 24x over that bottom squared. So the 24s add each other out, and we just have 8 over 6x plus 2 squared. We have to move over a board here. So our differential in C is going to be that thing evaluated at 1 times the change in x. Subtract the 2x's, our change in x is 0.04. So the differential in C, C prime at 1 times our delta x, which is 1.04 minus 1. So C prime was 8 over 6x plus 2 all squared. Let's put a 1 in there. I'll have 8 over 6 times 1 plus 2 all squared. And then this was 0.04. 6 times 1 plus 2 is 8. So I have 8 over 8 squared. So that's 1/8. That's 0.04. So I don't know, do you want it in fraction? Do you want it in decimal? How do you want your answer? 0.04 is 4 over 100. 4 goes into 8 twice, so 1 over 200 is about how big delta C is going to be.
Because the answer piece is 1 over 1600.
Well, then fix it. Yeah, I messed up the answer. 1 over 200. Okay. Correct answer. What did you say, 1600?
Yeah.
Yes, ma'am. Okay, so another one I messed up on, which one?
Right equation of 16. Y equals 2x plus 1 and minus 2. And all of that is 3 over 2.
All of that is doing what?
3 over 2.
To the 3 over 2 power? Equation of the tangent line at what point? When x is 4 over 3? That's awfully
Actually,
mean.
no, 4.
Ooh, that's better.
I will.
Right, this is on the review sheet as well? Which problem?
I just said it's letter X.
Okay. Equation of the tangent line at x is 4 to that function. So we're going to have to take the derivative, evaluate when x is 4, and that'll be the slope of the tangent line. I'm going to write that as 2x plus 1 all to the 1/2. 2x plus 1 to the 1/2 minus 2, and then all of that to the 3/2 power. So we've got to do some serious chain rule action here. Starting outside, bring the power down, leave that alone, raise it to 1 power less. That's a good one. Bring the power down, raise it to 1 power less. Now we go inside, multiply by the derivative of what's inside. So inside, I gotta do another power rule. Bring that 1/2 down, 2x plus 1 to 1 power less, and then multiply by the derivative inside there is 2. This last term has a derivative of 0. So we're done with our derivative. These two cancel each other out. This I'm going to put on the bottom with a positive exponent. So here's that 2. These two cancel, and now that with a positive exponent. Now the slope of the tangent line is found by replacing x by 4. We'll have 3 times the quantity. 2 times 4 is 8, plus 1 is 9 to the 1/2, minus 2, all of that to the 1/2. And then 2 here, and then I have a 9 to the 1/2. What is 9 to the 1/2 power? 3, it's a square root of 9. So 3 minus 2 is 1, 1 to any power is 1. So I just get 3. And then 9 to the 1/2 was 3, so down here I get 6. So sure enough, slope is a 1/2. So if I put a 4th on the review sheet, fix it. That's the M. Now I need the equation, which would be y minus y1 is equal to our m, x minus x1. So we got to go back up here and figure out what y is when x is 4. So we get y is equal to square root of 9 minus 2 to the 3/2. So again, I get 1 in the parentheses. So y1 is 1. So make sure you get a half right here instead of what I had on the parentheses. Those are the only 2 mistakes I have? Yes, sir. You found another mistake.
I mean, maybe. Number 3 goes, find the equation of the tangent line to x cubed plus y cubed minus 9xy equals 0. And then at the point 2 4.
All right, let's switch boards.
This is number 3. Yeah.
Okay, so I've given you an equation this time. In order to find y prime, you'll have to use implicit differentiation. So go through that equation, take the derivative, see if you can find an expression for y prime. Notice that that third term is 9xy, so that's a product rule going on there. And don't blow the sign in front of it.
I was confused when you mentioned, so you just take the derivative of the standard equation and you plug it in.
That should be to your benefit if I give you a point. Less algebra. Oh, you fool. Why is not done? Get that. Okay, so we said we have the same derivative. Take the derivative of x cubed and you get 3x squared. Trying to get the same thing for the y cubed, except that's now a function of x. So here you tack on the y prime term, however you write it, y prime would be y dx. And now in here, we're going to do the product rule. I'm going to call this the first term and that the second. So I'm going to keep the sign with the x term.
So with the 3, shouldn't the y be 3y
It
squared?
should be. It should be, thank you. Okay, so I'm calling minus 9x my first term, and then the positive y my second term. So I'm going to have my first times the derivative of the second plus the second times the derivative of the first. And the derivative across the equal sign gives me 0. And now you can put in 2 for x and 4 for y. So we have 3 times 2 squared plus 3.
You don't want to move everything over
I
yet?
can, but there's no need to. I just want the slope. I think when you're given numbers, you have to find the slope, it makes it quicker and easier. The first term is 3 times 4. 3 times 4 is 12. Then I have 16 times 3 is 48. Y prime. 3 times 9 is 18. 4 times 9 is 36. So these two together give me 30y prime. These two together give me a negative 24. I'm going to move that over and make that a positive 24. Now divide by 30. 24 over 30 is our slope. Those are both divisible by 6. I'm getting a slope of 4/5. On the answer sheet. So the equation should be y minus 4 is 4/5 x minus 2.
And on the test, that is sufficient.
Absolutely sufficient. Yes, ma'am. Equals 19 minus 17.
That's stuff. That's on.
We'll define the absolute max and min. On the interval from 0 to 2 pi. So we're going to have to collect our critical numbers. That means you need the derivative of this. Take the derivative, but pay attention, your first term has a product rule in it. S prime of t. The first times the derivative of the second. What's the derivative of the cosine of t? And the derivative t here inside the cosine is just 1. Then the other way, cosine of t times the derivative of that t is just 1. Then over here, the derivative sine of t is the cosine of t. So these two add each other out. We just have minus t sine of t left. So S prime is 0 when minus t is 0 and when the sine of t is 0. This gives us t is 0. In one period of the sine function, what are all the zeros?
Oh.
0, pi, and 2 pi itself. So the only one contributing to our evaluation is the pi. We're going to evaluate S at these 3 points anyway. So let me do my table this way. So 0, pi, and 2 pi. So in S, this last term is always 0 at those 3 numbers. When t is 0, the first t is 0, so that thing is 0. Then I have pi times the cosine of pi. What's the cosine of pi? So here this simplifies to negative pi. Cosine of 2 pi is a positive 1, so I have 2 pi times 1. So this one's the absolute max. This one's the absolute minimum.
On the first line, when you start taking the derivative, where did the negative cosine t come from?
Derivative of this term.
Okay, and then where did
This is the product rule. First, let's do the second plus second times the derivative of first.
oh, because you put cosine t in parentheses and then took the derivative and did the chain rule.
First is t, then the derivative of cosine t is minus sine t. Plus the second, that's the cosine of t, then the derivative of the first is just 1.
I had a question on this one.
Okay,
It was like find y double prime.
is it on the review?
Yeah.
Let me pull that up and you don't have to read it to me. I can find it. I thought I pulled, I did, I guess I didn't pull the review up, sorry. You'd have to look at it. 2x squared minus y to the fourth is equal to 8.
Like 3.6.
On the review, instructions are to find the second derivative. I'm the second derivative. So we got an equation again. We can find the first derivative just by taking the derivative of each term. Here, the derivative of 2x squared is 4x. But the derivative of y to the fourth will have the 4y cubed and then the y prime term. So I'm going to write it using the dy dx. And then the derivative of 8 is 0. So before we take the second derivative, we solve for this. So since that's got the minus sign, I'll just move that to the other side. And then divide everything by 4y cubed. And the 4's will cancel. So I have, let me write it in reverse order, dy dx is x over y cubed. I'm going to do the quotient rule to get the second derivative. So we're going to do the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom square. So I'll let you try it first. So the bottom was y cubed. And the derivative of the top is just 1, right? Minus the top is x. The bottom has as its derivative 3y squared, and then our dy dx. And then the bottom squared is y cubed squared.
I don't even know when to like actually do that or just leave it.
We need to just leave it.
Meaning like just y cubed squared, y to the fifth.
Oh, it's leave y to the 6th.
Oh, I did a 6, I'm sorry.
It didn't matter to me. As long as you don't put y to the 5th. Okay, so I'm going to have y cubed here. I'm going to write this as 3xy squared. And now we go to our previous step. We've calculated this to be x over y cubed. So I'm going to put that right here. And then here, when you raise a power to a power, you multiply exponents. Of course, you could leave it there, but I'm going to go further. That's why they pay me the big bucks. When I multiply this out, I'm going to get an x squared here. And then I'm going to get a y on the bottom here. Just at the bottom of this term. So this term becomes 3x squared over y. So I have y cubed minus 3x squared over y. And down here I have y to the 6th. And then if I want to clear this y, I'm going to multiply top and bottom of this fraction by y. So that becomes y to the 4th minus 3x squared, because this y is going to cancel. And then I'm going to have a y to the 7th. So the reason I did it like that was just in case somebody asked you to take a third derivative. You could do it more easily from there.
How far do you go in a test?
You can stop here. But since I simplified it for you, why don't you find, just for extra practice, the third derivative in terms of x and y only. Starting from here, do your little quotient rule again. And then replace the y prime that you got from the first step. So when you're at home by yourself, you let that snooze really go? Does that go loud? Or is it that silent up on to it? All right, you're at home. You saw it go by yourself. Right? When I'm at home, I shake the walls. All right, I'm ready to check the answers. Let me swap boards here. We can do the quotient rule on that thing. So we got the bottom times the derivative of the top. Bottom is y to the 7th. Now the derivative of the top. I've got y to the 4th minus 3x squared on the top, so the derivative of y to the 4th is 4y cubed times y prime term. And then minus the derivative of 3x squared, so minus 6x. The bottom times the derivative of the top. Now the other way, top times the derivative of the bottom. The top was y to the 4th minus 3x squared. And the derivative of the bottom is 7y to the 6th times the y prime term. All over the bottom squared. That so far? All right, I'm going to multiply this out a nudge, not much. And I'm going to replace this with what we got in that first line, dy dx was x over y cubed. So this becomes 4y to the 10th. Then my dy dx was x over y cubed. Now I take y to the 7th times the 6x, so minus 6x y to the 7th. This multiplied with this gives me 7y to the 10th, but now I replace that with x over y cubed. And then I got these guys multiplied together with that minus sign. I have a pair of minus signs to give me a plus. 1x squared y to the 6th times x over y cubed, all divided by y to the 14th. Make it prettier than that. Cancel here, leave me a y to the 7th. So we have 4x y to the 7th minus 6x y to the 7th. This gives me another y to the 7th, so minus 7x y to the 7th. This gives me an x cubed y cubed times the 21. So these three guys are the same. We can add them. 4x y to the 7th minus 6x y to the 7th is minus 2 of those. Minus 7 more gives me minus 9 of those. And then did you not get the common factor of y cubed? Of course. So that's gone. That's y to the 4th. That's y to the 11th. Minus 9x y to the 4th. 21x cubed. Y to the 11th. That was fun, wasn't it? Super fun.
Well, what's one, like this one, the test would be one that's like a polynomial, or would it be more likely one that's like a square root?
You don't like square roots for some reason?
No.
Well,
Or
I
don't you?
chose to simplify one the other day. Not work very well.
No, well, I won't make you simplify. But you are welcome to try to simplify. Yes,
So I think this is on the test.
stop right here. You want to replace your y prime term with your x over y cubed. Oh, yeah, you wouldn't have to multiply it out. Yeah. Unless I inspired you to do such. All right, we've got piecewise defined function, and we want to find the absolute max and min. Right, minus 4x, x squared plus 6x. it up around x is equal to 1.
Still.
Web work. This has to be. Always 0.04.
Which question? Okay. Saw that.
Okay, so is this function continuous on the interval from 0 to 4? You have a piece of a line and a piece of a parabola. So I know by themselves, the line and the parabola are continuous everywhere.
Well,
Do they hook up?
I think so.
That's a 5, that's a 7. Did I copy something down wrong? Is that a minus x squared? That's my bad. It's a minus x squared. And now they do hook up at 5. Right? They both pass through the ordered pair 1, 5. Agree? So f is continuous. That means it has to have. F is continuous on 0, 4. So it has to have an absolute max and an absolute min. So we look for critical numbers. F prime here is a -4 if x is less than 1. It's minus 2x plus 6 if x is greater than or equal to 1. So there's a critical number in the interval. That second little snippet there, set that equal to 0 and solve for x. And 3 is in the interval. So that's a critical number. And then tell me why I'm going to use x is equal to 1 is also a critical number. But remember we said if it's a continuous function, there's going to be places where the derivative is 0 or where the derivative does not exist. The derivative doesn't exist here because I've got a sharp corner happening when I change shape.
You're talking about at 1.
At 1, because this line segment here, here's x is 1. We said they both go through 6. So here's 1, 6. And then that one goes through 9. And it looks something like that. That's this piece. Then at 1, 6, oh, not 6, 5. That fills that in. And then I've got a piece of a parabola that when x is 3, 3 is 9, that's 18, looks something like this. Right, so there's no derivative at a sharp corner. So x is equal to 3 is going to give us a critical number. Sharp corner is going to give us a critical number. And then we're going to cut this off from 0 to 4. So in here and here. Rub that out. Rub that out. We'll find those y values there and see which one is tallest and which one's the shortest.
You say x equals 1 is a critical value, but
does not exist.
That corner.
Right.
Got a graph that's going to change shape. This point's going to give you no derivative. All right, so I've got to go back to F and plug in 3, 1, 0, and 4 and see which gives us the largest Y value. Okay, so to plug in X is 3, I have to use this piece. X is 3 qualifies to be on here. So I get minus 3 squared plus 6 times 3. So I have 9, minus 9 plus 18 is going to give me 9. X is equal to 1 is also here. So I get minus 1 squared plus 6 times 1. So I get minus 1 plus 6 is 5. X is 0 is on this piece. So I have 9 minus 4 times 0, which is going to give me 9. X is equal to 4 is here. So I'm going to have minus 4 squared plus 6 times 4. Minus 16 plus 24 is a positive 8. So in that list, 9 is the biggest number, 5 is the smallest. These two guys give us the absolute max. And this one's the absolute min. Oh, we got time for another one. All of our derivative rules for our transcendental functions. Make sure you know the derivatives of all the trig functions, inverse trig functions, e to the x, natural log of x, 6 to the x, log base 6 of x, the arctangent of 6 to the x. What is the derivative with respect to x? The arctangent of 6 to the x. First thing, what is the derivative rule for the arctangent of u? What is it? All right. And then the derivative with respect to x of, say, 6 to the x. What's that going to be?
6 to the x times -1 of 6.
That's going to be it because the derivative is 1. So put these two together, and this should be u prime, 6 to the x, natural log of 6 over 1 plus u.
By that is 2u. Or 2x, I mean.
Yes, you could write this as 6 to the 2x. Raise a power to a power, you multiply exponents. Or you could square the 6 and write that as 36 degrees. Remember all those rules? Yes, sir. What'd you find out? Yep, we did. Or if you don't want to memorize it, you can derive it. Right? You can always do the logarithmic differentiation. All right, so what if you did forget a rule? So what if you forgot how to take the derivative of y is equal to the arc sine of x? What if you forgot that derivative? Well, you just rewrite this first as the sine of y is x. Take the derivative of both sides. Solve for y prime. But from here, if I know the sine of y, I can get the cosine of y. Right? This is the right triangle here, and this is angle y. Sine is opposite over the hypotenuse. What's going to be the length of this side?
1 minus x squared.
And that's going to be the cosine of y, because it's adjacent to the hypotenuse. So that gives me the derivative of the arc sine. So if you forget, you can always do implicit differentiation. Okay? It's okay? All right, I'll try to put enough problems on there to keep everybody happy. If I don't put your favorite problem on there, you're always welcome to add it. I'll put extra credit on there.
Sounded like if we add our own.
If you add your own, only if you do it right.
What if we add our own and do it wrong?
Well, then I oughta,
You get kicked out.
then I'll erase,
You get expelled. Right.
figure something out. All right, do well on this next one. Do well. Recording.